Hello everyone, welcome to the third lecture of Basic Electrical Engineering Module 1. Today I'll discuss about source conversion technique, but before going to source conversion technique, I would like to recap on whatever was done in the previous lecture. So in the previous lecture, a very brief discussion was given on different types of circuits, DC circuits, the different types of circuits, different types of components, elements present in a circuit. Those things were discussed, and different types of sources were discussed. Now, after that, Kirchhoff's law, which are of two types, Kirchhoff's current law and Kirchhoff's voltage law, those were also discussed, and also application of Kirchhoff's law was discussed. Applications in terms of nodal analysis and applications in terms of mesh analysis. Both methods were discussed. These methods are very important for solving DC problem. So now I'll move to another topic, which is source conversion. This method, when applied, is also makes the circuit simple to solve. So these methods, nodal analysis, mesh analysis, source conversion, all these things are required for solving problem. So let us now move on to source conversion. Now source conversion, before going to source conversion, I would like to clarify a few points about source. Source can be of two types, current and voltage source. Okay, now current source and voltage source, they are broadly divided into dependent and independent sources. Dependent sources I have already discussed in the previous lecture. Independent sources are those sources which does not depend on current and voltage of the circuit. Okay, those are independent sources. So in the present module, only independent sources are covered and not dependent sources. Dependent sources are mainly covered in higher semester. So in this semester we'll discuss about only independent sources. Okay, now source conversion, as I said, there are two types of sources, current and voltage sources. Now one voltage source can be converted to a current source, and a current source can be converted to a voltage source. That is called source conversion. Now how it is done, that we will see. A given voltage source with a series resistance can be converted into an equivalent source with a parallel resistance. Say this combination. A given voltage source, any given voltage source in series with a resistance. This combination should be there. No other resistance, no other component should be present between these two, and these two should be connected in series. When this configuration is present, then only it can be converted to a current source. Okay, so when a voltage source is in series with a resistance, it can be converted to a current source. This would supply, it can be converted to a current source in parallel with the resistance. Now what is the value? The resistance value remains the same. See, this resistance and this resistance, the value remains the same, only the current source value changes. And how to find out this current source value? We know I is equal to V by R, so this V divided by this R will give the amount of current I. Okay, this current source, the value of this current source can be found out by dividing this V by this R. So this value of I is V by R, and the resistance is as it is. The resistance value will remain the same. So a voltage source connected in series with a resistance can be converted to a current source in parallel with the resistance, having the value of current as V by R. Conversely, this current source can also be converted to a voltage source. This combination should be there. Again, there should not be present any resistance here in between or any other component here in between. A single current source in parallel to a resistance should be there. When this combination is present, then this can be replaced by a single voltage source in series with the resistance. Now as the previous case, resistance remains the same, this resistance and this resistance remains the same, only the value of V will change. And how to find out the value of V? V is equal to IR, so this value of I into the resistance R, V is equal to IR, will give the value of this voltage source. Okay. A current source with parallel resistance can be converted to a voltage source with a series resistance, and this is how we find out the value of current and the value of voltage. So this is source conversion. Now I will move on to problems. As I said earlier that I will discuss each and problems related to each and every law or method which we are discussing. So first let us see we are taking a very basic example. What is the voltage Vs across the open switch in the circuit shown below? This is the open switch, and what is the value of voltage appearing across this? It is marked as Vs and the sign is minus plus. Okay. Now we'll apply KVL here. Okay, we'll apply KVL. Suppose we are going in the clockwise direction. Again, it depends upon you. You want to go in clockwise direction or anti-clockwise direction. So according to KVL, the summation of the voltage drops and EMF should be equal to 0. So if I move in the clockwise direction and I'm starting with the voltage source Vs, okay, this voltage Vs. So since it is clockwise, so it is rise in potential because it is from minus to plus. So my plus of Vs. Now when I come to this, again it is minus, this is plus. So it is minus to plus, so rise in potential is there. So it will be plus of 10. Now when I come here, this is plus and this is minus. So it is going from plus to minus. That means it is dropping. So it will be minus 20. Drop in potential is there, so it will be minus 20. And if I come here, again plus minus, so drop in potential is there, so it will be minus 50. And if I come here, it will be from minus to plus, so rise in potential, so it will be plus 30. And all the other values are known except this Vs. Except this Vs, everything is known, so we can easily find out the value of Vs from this equation. This is a very simple application of KVL. Now next question, find the unknown voltage V1 in the circuit. Okay. V1 is, yes, this is V1 with the voltage drop across R1. This is V1. So how to find out this V1? Now see, when we are finding this V1, we need all the other variables to be known. There should not be any unknown variable present, then only we can easily find out. So now in this we don't know if I take this loop, this resistance, current flowing through this resistance is not known. If I come here, this big loop if I take, then again the current flowing in this branch is not known, right? So what happened, let us take this bigger loop, biggest one, A B C D E F A. This biggest loop let us take. Now see, this is known, this is we need to find out. Current flowing in this branch is known, so drop we can find out easily. Again current flowing in this branch is known, so drop we can find out easily. So everything is known except this V1, right? So we can use KVL in this biggest loop. So taking the outer closed loop A B C D E F A and applying KVL to it, we get, now suppose we are starting from here, or we can start from the voltage source, there is no problem. Let us start from the voltage source. Voltage source, again direction, see the direction of current, this is the direction of current, right? Clockwise. So rise in potential, so it will be plus 40. Resistance, drop in potential will be there, so it will be minus V1 into R1. Oh sorry, minus V1, the drop is minus V1, and here drop is what, 16 into 3, I is 16, R is 3, so 16 into 3, since it is drop it will be minus. Next come to this element, 4A ampere current, 4 ampere current, 2 resistance, so minus of this into this, minus of this into this. So the whole loop is completed, right? We cannot leave a single element. We'll have to consider all the elements present in the loop, otherwise the problem will be thus you will not get solution. Okay, you will get a wrong solution. So we need to consider all the elements. Now see, 1 2 3 4, four expressions are there. 1 2 3 and 4, four expressions are there. Four elements, four expressions. Okay, so the loop is complete. So this will be equal to 0 according to KVL. Now only v1 is unknown, so we can easily find out the value of v1 from this equation. Now one thing I would like to clear here, see here it is mentioned loop. Now this is a loop, this is a loop, this is also a loop, right? This biggest one is also a loop, this one is also a loop. A loop is any closed path. Okay, any closed path is a loop. Now the smallest path, smallest closed path, this is the smallest closed path, this is the smallest closed path, this is the smallest closed path. One individual closed path, that is called mesh. Okay, mesh is the smallest loop. A loop can be a mesh, but a mesh can never be a loop. Okay, keep in mind always, this is a mesh, this is a mesh, but this combined as a whole is not a mesh, because in between there are two meshes. So this combined bigger one is a loop and not a mesh, but this smaller one, this smaller one are meshes. So this is the difference between mesh and loop. That will be important and it may be needed in the further studies. So I just explained what is the difference between mesh and loop. Okay, now move on to next problem. Okay, determine the current supplied by each battery in the circuit shown. So we need to find out the current of each battery. How many batteries are there? 1 2 3 4 5. 5 batteries are there. So we need to find out 5 currents which these batteries are supplying. We can say these batteries are supplying, let it be. So if we apply mesh analysis here, we'll get 3 meshes. 1 2 3. Okay, one mesh, sorry, one mesh, 2 mesh and 3 mesh. And we consider, as I said earlier, we'll consider a single current, single mesh current flowing in a single mesh, right? So let it be I1, I2 and I3. Direction depends upon you, which direction you want to take. I have taken this way, clockwise, clockwise, anti-clockwise. Okay, based on the direction only your equations will be there. And don't worry, at last after solving the equations, whatever sign you are, whatever direction you choose, you will get ultimately the correct answer. And if you are getting current as negative, that only means that the direction which you have chosen is opposite to the actual direction, nothing else. You will get the actual value. The magnitude will remain same, only sign if it is coming as negative, that will only mean that the direction which you have chosen is opposite to the actual direction. Okay, now we'll consider for loop 1. This is loop 1. Okay, so see, loop 1, in loop 1 I1 current is flowing. So I1 is flowing through this battery, I1 is flowing through this resistance, I1 is flowing through this 3 ohm resistance and 5 volt battery. But see, this I2 current, it is also flowing through this 5 volt battery and 3 ohm resistance. So in this particular branch, two currents will come into picture, I1 and I2. So the net current flowing in this branch will be the algebraic sum of I1 and I2, or okay, net current I1 minus I2 or I2 I1 plus I2, it will depend on the direction again. Suppose we are writing for equation for the first one. So the direction is like this, right? It is clockwise, so it is rise in potential, so it will be plus 20. Drop in potential, so it will be minus 5 into I1. Now come here, here two currents are there. I am coming with a current I1, and on the way I find I2 which is in the opposite direction. So net current will be what? It will be I1 minus I2. I1 minus I2. So here drop will be I1 minus I2 into 3. Okay, and what about this battery? This battery is in the opposite direction, plus to minus, that is dropping potential, so it will be -5. So on solving this, we'll get this equation number, let it be 1. Similarly for loop 2, now see, for loop 2, this resistance and this voltage source, only one single current I2 is flowing, but this branch there are two currents net will flow, two current I1 and I2. Here net of two current I2 and I3 will flow similarly in this branch, right? So let us write the equation. For this it will be minus of 4 into I2, okay, because only I2 is flowing here. So minus of 4 into I2. Here see, rise in potential, because direction is this, so rise in potential it will be plus 5. Then here say I am going with a direction with a current of I2, and this current is also coming along with me, right? I3 is also in the same direction, this is also in the same direction. So both, since both are in the same direction, they will be added up, so it will be I2 plus I3. Here I2 and I3 will be added up, I2 plus I3, okay. Then drop will be minus 2 into I2 plus I3. Here rise in potential is there, so it will be plus 5. Here rise in potential is there, so it will be plus 5. Drop in potential minus 3 into, but the current now I2 will be dominating, because I am considering I2, this branch, this mesh, so it is I2 minus I1, so minus 3 I2 minus I1, okay. So upon solving this equation, we'll get an equation in terms of I1, I2 and I3. Now for the third loop, see, this direction is this way, in the anti-clockwise direction. So if I consider anti-clockwise, this is rising, plus 30, minus of 8 into I3, drop in potential, so minus 8 into I3. Here again, if I consider I3, I2 is also coming in the same direction, so it will be I2 plus I3, minus of 2 into I2 plus I3, and this is in the same direction, so rise in potential. So see, minus 8 into I3, minus 8 into I3, plus 30, plus 30 because rise in potential, minus 2 into I2 plus I3, minus 2 into I2 plus I3, and plus 5, okay, plus 5, yeah. So upon solving this, we are getting this equation, okay, this equation number 3. So we have three variables, I1, I2, I3, we have three equations, 1, 2, 3. So three variables, three equations, we can simultaneously solve the equation and find out the value of I1, I2 and I3. So easily we can find, once I1, I2, I3 are known, so the current supplied by this source is known, current supplied by this source is known, and current supplied by this source is known. But the current supplied by this source will be the net of I1 and I2, and current supplied by this source will be net of I2 and I3, okay, because here net current will flow. Next, move on to next problem. Using nodal voltage method, find the current in 3 ohm resistor for the network. 3 ohm resistor, this one. So we need to find out the current in 3 ohm resistor. That means the current flowing in this branch, because it is the same, the current flowing in this branch will be the current flowing through 3 ohm resistor, and it is mentioned that nodal analysis method you will have to use. So if it is mentioned to use a certain method, you will definitely have to use the method, otherwise you will not get marks. Like in the previous question, it was not mentioned which method you should use, right? So it is up to you which method is convenient, you are comfortable with. But if it is mentioned that you use this method, you are bound to use the method, otherwise you will not get marks, okay. So let us move on. Nodal analysis is what? In nodal analysis, what we do, it is the application of KCL, okay. So we consider current coming to this node is equal to 0. Sum of current coming to this node 1 is equal to 0. Node 2 is a reference node, as I have explained earlier what is reference node, okay. So if I take this as positive, I mean this as coming to the node, direction is from left to right, here direction is from right to left, and here it is from, it will downwards. Okay, so sum of this and this will be equal to this. Sum of coming to the node is equal to leaving the node. So coming to the node, see here 4 plus 2 plus, because both are in the same direction, and let this voltage be V1. So 4 plus 2, 6, minus V1, drop in the lower potential is V1. So 6 minus V1 divided by the total resistance, that is 5. Okay, 5. Now for this, 4 minus V1 by 2, 4 minus V1 by 2, and for this it will be simply V1 by 2, because this is at 0. So from here we have got the value of V1. V1 is 8 by 3 volt. This is V1, 8 by 3 volt. Now we are asked to find out the current flowing through 3 ohm. So current flowing through this is nothing but 6 minus V1 by 5, right? This is the current. So V1 is known. Now you can easily use and find out by using this equation, this particular expression. Okay, this way we can find out the current. Now next question, use source conversion technique to find the load current I in the circuit. Now which is load current I? Okay, this is the load current. So the current flowing through this branch will be the load current. Okay, the current flowing through the load will be the load current. So it is also, see here also it is mentioned to use source conversion technique. So you will have to use source conversion technique. Okay, so see, follow this circuit. See this circuit, a voltage source in series with a resistance is there. So like I explained earlier, this voltage source in series with the resistance, if this combination is there, this combination can be replaced, substituted by a single current source in parallel with the resistance. So this single current source in parallel with the resistance value will remain same, 3, and what is the amount of current? It is 6 by 3 V by R. So 6 by 3, that is 2 ampere. Okay, so after converting this to a current source, we are getting this part. Rest will remain as it is. Rest part, this whole thing will remain as it is. See, the whole thing will remain as it is. Nothing is changing. Now see, these two resistances are in parallel. We can easily find out the equivalent. See, 6 and 3, these two are in parallel. So we can find out the equivalent and we'll get it 2. Now what is there? A current source is there, a resistance is there in parallel. So a current source in parallel with the resistance, this combination can be replaced by a single voltage source in series with the resistance. A single voltage source in series with the resistance. See, this whole thing, this complete part will be replaced by a single voltage source having a value IR, I into R, 2 to the 4 volt, and the resistance will come in series with the voltage source. So this part is gone. This is simplified. Now this part remain as it is. So 2, this part see remain as it is, right? So now these two are in series. Will combine this to a single resistance, it will become 4. Now this combination will again be replaced by it is again converted to a current source. So 4 by 4, because this 2 is 4, so 4 by 4 will give you 1 ampere current, and the series the resistance will come in parallel having a 4 ohm value, right? Then we are having a current source, a resistance in parallel. Now see, this current source and this current source, there is no other resistance in between except this is parallel. In series no resistance is there, here no branch resistance is there, and nothing. So this current source and this current source can be combined and replaced by a single current source. What will be the value? Again, it will depend on the direction. See, it is minus to plus, so the current direction is this. So it is current direction is this, current direction is this. So these two current sources are in giving current in the same direction, so it will be added up, and a single voltage source, current source will come having a value of 4 ampere, 3 ampere, 1 ampere will give you 4 ampere in parallel with the resistance 4. Okay, now see, the circuit is simplified. See, from this complex circuit we have simplified it to this circuit by using source conversion technique. Now see, this current source, easily by using current divider rule we can find out the value of current flowing through the load, that is the IL. For the 4 ampere current is divided into two equal parts at point A. Yeah, two equal parts, because this 1 ampere, 1 ohm and 3 ohm will give you 4 ohm. So this current, this resistance is 4 ampere, 4 ohm. This total resistance is 4 ohm. So when two equal resistances are connected in parallel, the current will be equally divided. So this 4 will be equally divided and we'll have 2 ampere flowing through the load resistance RL. So this is how we solve by using source conversion technique. Again, source conversion technique should be applied to make your circuit simple and not complex. Okay, it is applied to make your circuit simple and not complex. Now see here, you are asked to find out the current flowing through RL. You could have easily said that this parallel resistance, this resistance in parallel with the current source can be replaced by a voltage source. But what is the use? Because you are merging this resistance which you need later on to find out the current flowing through this branch, right? To when while calculating the current flowing through this branch, you will need this resistance. Now if you collapse this resistance by converting it to a voltage source, it is of no use. So this should not be done. So always keep in mind, while using any technique, not only source conversion technique, nodal analysis or mesh analysis, any technique if you use, it should make your circuit simple. You should always use such a method which will make your circuit simple and not complex, that you will have to understand by yourself. Now at the beginning stage, at the initial stage, it will be very difficult for you to find out which method is suitable, what should be the next step to which should be followed to solve the circuit. But as days pass by rigorous practice and continuous study, and studying different types of circuits, continuous practice trying to solve different types of problems, you will yourself build up that that habit of finding out which method will be suitable to solve this part. When you are given with a circuit, you will easily, instantly, you can say which method should I apply to solve this circuit. So it will again come with rigorous practice. So you will have to practice. Let it be for any method, you will have to practice. Otherwise you cannot choose which method you should apply to solve. Okay, and what way you should. Like here it is mentioned to use source conversion, that is okay, but source conversion should be applied at this side or this side, that you will have to decide. Okay, that will come through practice. So this was all about the numericals related to nodal analysis, mesh analysis and source conversion technique. So for today's lecture I will stop here, and as you can see this, I will move to theorems. Now there are certain theorems which you need to know to solve circuits again. So those theorems I'll be discussing in the next lecture. So for today I'll stop here, and I will expect that you people are practicing the methods which I have already explained. Try to solve more and more problems by using the methods, and let me know if you can solve it or not, and definitely feel free to ask me any doubt if you are having. Okay, so thank you for today. I'll stop here. Thank you for your patience and time.